if we believe that services should respect our rights. That's why we work with the organisations who are shaping our digital world to show how they can be trusted with data. Our work at IF is increasingly taking us into all kinds of machine intelligence technologies. We look specifically at how individuals, end consumers or members or users, are able to trust services that are powered by machine intelligence technologies, but also how machine intelligence can be trustworthy in the first place, and by which I mean also safe and accountable. Thanks. That's really important because increasingly machine intelligence is powering really important and also sensitive areas of our lives, like helping you to find a job or to manage your finances or perhaps to receive treatment for a medical issue. At this point, I'd like to reframe what I mean by machine intelligence technologies. Matt Jones from Google AI uses the term learned systems, and I think it's a really effective phrase to focus the issue on people and society. It also reminds us that we teach these systems and we build them too, and that they operate within a real-world context. So I like using the phrase learned systems because it reminds me of these things. Today, I'm going to share 8 characteristics with you that we found from our work at IF. Characteristics we think that make a safe and accountable learned system. I'm going to show you some examples from our work with clients. I'm afraid I can't show you all examples because I'd be in breach of confidentiality agreements. But I have found examples from the public domain and our blog to illustrate these points. So the first characteristic is that a learned system that is safe and accountable should make its decisions legible and understandable to the people who use services powered by it. It's a bit like handwriting. If you have messy handwriting, it's not legible. It's very difficult for someone to read your handwriting or what you've written. And it's kind of the same for services. I think at the moment we are building services that are really difficult to read. They're illegible. It's very difficult for you to understand how that service works, what inferences it might be learning about your behavior, what data it collects, when, why. And you have to question that even if we did make services more legible, would people be able to understand them? At the moment, we rely purely on terms of service or terms and conditions to do a lot of that work for us. But we know that they're just not good enough for the digital services we use today, let alone this world of services that are powered by learned systems. At IF, we think it's possible to start designing terms of service out by putting that level of understanding about how a service works, what data it collects, what inferences it's using, all at point of use. The example shown here to the left is of a fictional benefits service that we developed for a parliamentary inquiry on algorithms and decision making. The screen shows you a screen that someone will see if they receive a benefit. And they're alerted to the fact that that benefit has been sanctioned, it's been reduced. By following that orange bar, they're then able to see why that sanction was given. So they can see why the decision was made and some of the information that was used to make the decision, all at point of use. They're also given the option to appeal, which I'll come back to later. The tricky part here, of course, is that learned systems are essentially non-deterministic. As an interface designer, you might be used to designing for a fairly well-known set of constraints, pretty much if this, then that. But with learned systems, there is an infinite number of possible interfaces that an individual might see. So you then have this rather tricky situation where you don't know, as a designer, what someone might experience in the application that you've developed. That's challenging when you think about how trust is formed. You might have conversations with members of your family or your friends to talk about, this is what my app's showing, what does yours look like? How will that work if we're all seeing different things? How will you build that trust with the service? The second characteristic of a safe and accountable learned system is that individuals should be able to override the learned system. That's important because trust is a two-way relationship. It really wouldn't be any good if learned systems were to give you decisions or make decisions on your behalf, but not let you give it feedback or to redirect it if there was something that you didn't agree with. It's very important that individuals are able to override during critical automated processes. A good example of this is Transport for London. Every Sunday, Transport for London revert to manual braking on the underground to prevent skills fade in their drivers as they use an automatic braking process. Recovery also needs to be graceful. By this I mean these learned systems are going to go wrong. Something's going to happen, and we need to be able to revert back to a previous version where that error didn't exist, or someone needs to be able to say stop, edit data that's being used, correct it, and then revert back to the decision-making process. And that all needs to be possible without having total failure of the system entirely. So that's what I mean about graceful recovery. An example is cruise control in a car. You can put a car into cruise control and do most of your journey quite happily using cruise control. But when you see a complex junction up ahead or something unusual, you need to be able to take the car into manual and take over yourself. And I think that's really important for all learned systems, that we're still able to do that. The fourth characteristic is about openness. If we believe that a safe and accountable learned system must have parts of it that are open, perhaps cooperative, commonly owned, but essentially not part of the market. That's because we need to have transparency built into these learned systems so that society can look ahead and course correct before anything goes wrong and harm is caused. Part of that transparency is also being able to verify who has access to what data, when, and why. That's a really important part of any system that you're going to trust. If we've been working with DeepMind Health to develop this prototype card reader. The card reader works on NHS staff card infrastructure. It builds on top of that to add another layer of authentication. It uses NHS staff cards and a clinician's identity to verify what access a clinician has to particular kinds of data. The sixth characteristic is that the needs of different levels of society need to be considered. That's because it's just not good enough to think that trust will be an individualistic action or purely an individualistic action. I think very few of us have got the skills all the time to understand how learned systems work and which ones we can trust or not, let alone how we might advise our friends or members of our family about what to trust. I think it's really important that we build in ways that individuals can look to groups to help us make those decisions, whether those be individuals or groups of people who can represent many of us, or existing or new institutions. To give an example of that, we go back to the fictional benefits service I mentioned earlier. You can see a fictional screen for citizens' advice. That individual who received the sanction appealed the decision. They felt something wasn't quite right. And so they go to citizens' advice to speak to an advisor to find out what can happen. And the advisor is able to call up their casebook and to see what decisions have been made to ultimately give them their sanction. And they can see which decisions were made by machines and which were made by humans. What's interesting is the part we've pulled out. The advisor is able to add this person's case to 153 other people in that area of the city who have missed appointments. That's so that the advisor can alert the organisation that there might be something wrong with the automated decision that is deciding which individuals should receive sanctions. We also think that the system's intent must be made clear and public for a learned system to be safe and accountable. That's because when you have a learned system working on your behalf, making decisions for you, whether that be what brand of loo paper to buy or what school to send your child to, I think we need to be clear on whose interest that system is really working to. As humans, we have some sense of morality, some idea of what is right and what is wrong. So how can we give what is essentially a bunch of numbers that understanding about what's okay and not okay? Even then, you have questions of okay for whom, not okay for whom. Every system has positives and negatives. And I think we need to be very clear about to whom harm is caused by these systems. It's just not good enough to just publish your ethics principles. You need to be making it very clear about who is hurt or who doesn't benefit from a system you might make, because I think we need to have public scrutiny on what negative consequences we decide are simply not okay. And the final characteristic I'd like to share with you today is about testing. Because to have a safe and accountable learned system, we think that it should be tested regularly, and that testing should be of the digital world. That's because any system of any complexity has always required testing. Take your fridge at home. Your fridge will have undergone testing from the manufacturer to make sure that it doesn't set alight in your kitchen, that it keeps food at a temperature that's safe to eat at, and it would have been built to standards that we agree as a society is how you should build a fridge. I think any learned system will need similar forms of testing, but they will look different because a fridge's performance will only change with age as its performance deteriorates, whereas we're suggesting with learned systems that they might change in moments. We need to start thinking about what these testing ecosystems are going to look like that can keep pace with the change of software. So I've given you a quick download of 8 characteristics we believe are make a safe and accountable learned system. There are more, and I wonder which ones you would add. I want to conclude by saying that alongside the technology that we're celebrating at CogX, we also need to consider the roles of regulation of new and existing institutions and of society, because only then, by considering the whole system, are we able to ensure that machine intelligence is safe and accountable for people. Thank you.